Oh, okay. I have an introduction. Hello, everyone. Good start. Thank you, Agnes, Brandon, and Chris, for inviting me to speak. I was originally going to be an attendee and was really, really happy to be slightly more than an attendee, to be able to contribute back. I apologize for hiding away in the corner as well. I was ill bit yesterday, so I'm just kind of tending to myself. So for everyone that was at NS Budapest on Thursday, this is the same first slide. It's actually a different presentation. But I can't carry on like this because you all know that the controls I was doing weren't easy. They were complex, which is why that doesn't actually make sense. So come on. Okay. So I'm going to at least try and make a consistent complex UI control, which is, I think, useful in a UI control and something that shows state or is meant to set state. You want it to be setting the state that you think you're setting. How am I going to do that? I'm going to put this down. We're going to do it using immutability. I'm not going to try and sell you on the benefits of immutability. I think other people already have already. And also, since we're at FuncSwift, we're going to probably use some functions as well. Cool. Oh, thanks, Daniel. Okay, we have a spec. This is the control we're going to make. It is a glorified segmented control, but it's got a few extra things. So I'll go over it. So for the consumer, we have a value which is the selected value, again analogous to a UI segmented control. The other thing that we need to do to be able to represent this control, it has a value, and then we need to show how do we represent that value, how do we draw it, how do we show it on the screen. So on the value side, there's a selected segment, like I said. I'm going to say segment a lot during this talk. So if you were to have a drinking game, like every time I say segment, take a drink, you would be very hydrated. We have also, as part of the spec, this thing called a null segment, which is a no selection, which can be there or not. In some situations, we're allowed to have a no selection. In some others, we can only have selection. So again, this is analogous to a UI segmented control that can have an NS not selected, which is basically a -1. There's no selection. So far, we're going to represent it like this. It's got a selected segment. That's not too complicated, but we're not finished. So how do we draw it? There was a track, which you can almost see. That's not too complicated, and what's interesting is that doesn't actually change. Nothing that we're doing to the control or getting from the control affects this track. So we can just draw it without a problem. It doesn't have to be reflected in the state. There's a handle which, as you might imagine, can move anywhere within the track, anywhere around the edge of the circle. Again, how we draw that is we have a container layer and a handle layer to draw a circle. The reason for this is we can do a simple transform on the layer with a much higher resolution than that to rotate it at any point we want around the circle. So to draw that, we need to know the angle. The next thing is segments. So there's a few different intricacies in how we're drawing these segments and what they represent. So the first thing is there's going to be an arbitrary number of them. So there was 4, and we'll increase it now to something larger than 4. So we're going to need to know the number of segments. And to draw those arcs, not only do we need to know the number of segments to divide 2 pi to get the angle of the arc we want, We also need to know whether or not we have a null segment to see if we need to take a constant bit at the top for a no selection into account. So we add a used null segment which is a bool, and a number of segments. So right now this is what we're going to use to represent it. So the selected segment we talked about, and that's already it's already included for our first thought about it, which is the value. There's one more thing, which is an invalid segment. So some context of this control. It's used first off to select the number of guests. It's for a restaurant booking app, to select the number of guests you have at a table. And for certain numbers of guests, there may or may not be available tables. So you can scroll to 2 guests. There may not be anything for 2, but for 3 they could be valid. So what does this mean for the control? What does the control need to know? Well, it has no idea of the state of the restaurant necessarily, but to draw it, we need to know what color we're drawing the segment. So we need segment colors, and we can wrap this in a data structure of segment, but at the moment we're just giving it a color to display. And obviously these the indices of these segment colors should match up to your the segment number. We also need to keep track of tracking. So when the user has their finger on the button, we've got a selected segment showing, and when they remove it, it goes away, because we have enthusiastic designers. It's good. I love working with enthusiastic designers. It makes things interesting. So we'll take a step back. Like, what have we got so far to represent this control? So all these. This is an immutable data structure, points. But one thing at the moment we're lacking is a consistency, which was, on the title, so I got to touch it. So let's take an example of, we'll create a dial view state which has a selected segment of 2, an angle of 0, a number of segments 10, and I've put 1 segment color. So there's a few problems here. That's a speaker note. So we can't tell what color any segment from 1 to 10 is. We only know the color of the first one. We can render the angle fine, and we can render the selected segment, but they're not the same. I think by definition it's inconsistent, and this is not what we want. So how can we keep all of the information we have to always say the same thing? We definitely need the handle angle or some kind of way to represent where on the circle it is. I mean, it could be something, it doesn't have to be represented in radians, it could represent it between 0 and 1 or a percentage. But either way, we have to be able to represent where to draw that handle. The same with the null segment and the segments. We need to know how many segments there are, and whether or not we're using a null segment to see how big our arcs need to be drawn. The selected segment we can actually derive from the angle. I'll show you that in a sec, just to convince you. And of course, the number of segments we get from the count of the segments we give the control. And just for reference, basically how you'd get the selected segment for angle. But it's not too important. So now we can have a data structure that looks a little bit like this. And for any value we initialize this with, it makes sense to show. And it also has a value that the consumer can query, which is a selected segment. So a little bit on rendering. I won't go too much into that, and I gave a little bit of CA layer code. But The handle layer will just get a transform, as I mentioned earlier, and that we can get directly from the handle angle if we give it to it in radians. The segment highlight layer, which is something I kind of made up for the purposes of drawing the highlight arc. This can be calculated with the state, which I haven't done here, but it's basically get the number of segments, divide 2π by that number of segments, plus 1 if you're using a null segment, and then the offset is going to be 2π over number of segments times whatever index you're at. But it's just a lot of geometry, which isn't the focus of this talk. So the next part is we've got some consistent state. We probably want to change it. Right now, we can definitely draw this state, but that only helps us once. And not unlike the previous speaker, we are going to instead introduce a set of changes that you might want to do. So we're changing state. In my speaker notes, I have wait for chuckle. How are we changing? Still wait for chuckle. So there are two things that are going to happen here. One is user input, obviously. It's a UIControl. And what can they do? They can tap it, drag it, touch it, play it, stop it, format it. So how are we going to deal with that? The user input we have for this is quite restricted. So we're going to take their touch or their drag. We'll make a gesture recognizer. We have a custom gesture recognizer, which we call a swirl gesture recognizer, which just does a little bit of geometry, which says at what angle the user's finger is in at any one point. So this gives us an angle, so what's changing is the angle. I'm sorry, I'm shouting. The selected segment, so we probably want to set a selected segment as well. The user of this control may want to say, okay, well, we're starting the controller at this particular value. So the controller might say set segment, which is actually setting an angle again. So instead of set segment, we've got set segments. We've got an arbitrary number of segments, and not only that, we've got those the invalid segments, which I said earlier, or any other sort of different colored segments. So this might be if we want to change the number of possibilities we have, or whether or not a possibility becomes available or unavailable. And then we've got set null segment and set tracking. So these are a set of possible changes we have. There's nothing else we can do with our state. We say this explicitly. So I promised you a function. Here is one. Thank you, Chris, for the formula support in Dexit. Here's one that looks even mathsier. So we've got a state, and we've got a delta, which is the squiggle. The squiggle that isn't an S. So our S are in the set of valid states that this the DAL view state can be in, and the deltas are the set of changes, and we can model that quite easily. We've got an angle which has an associated angle, a null segment turning it on or off, changing the segments, which has an array of segments, and tracking, again with an associated Boolean. And so how do we use this? We have a function which gives us a valid state. In this case, actually, the changes are pretty trivial, so I won't go too much into it, but you can imagine, say, for example, in the case of changing the angle, we return a new dial view state with just a new angle that we've given it with that change. Similarly for tracking and all of the other state changes. So we've got a view that's drawing this state. When something changes, we set its new state with the change, and then we want to render it. So if we've got this view, we just we draw it, so it represents what our new change is. The biggest gain, and I think what I wanted to get across from that is that with this, we're always rendering a valid state, and the asterisk is for some point in time. Things can happen that changed our state later on, but at the time that we drew it, and for whatever value that represents to the user or the user input, they're both consistent with each other. So the user couldn't, the consumer of the API that wants to query what value it is could never get a value that wasn't being shown. So anytime we ask for it, it'll be consistent, which is really important for a UI control. You want what you think it's controlling to get the value that you're trying to put into it. So I kind of raced through that, which is I think okay. But what I'd like to do is just show it to you because I've spent a lot of time on it. I thought my phone got really thick for a second. It's really quiet. Thank you. This may result in a massive anticlimax. It will. Shall we pretend it worked? Cool. And there it was. Thank you. Thank you. I really appreciate you sticking around for that. If any of you are really that interested, please come and ask me, and I'll show it to you in person, which is going to be even better because you can play with it yourself. And that was it for me. Thank you very much. There's a few things I didn't touch on, which if you want to ask questions about, that'll be fine. I'd love to chat more about this on Twitter or in person or a mixture of the two. Thank you. Question? Yes.
So how do you handle animations, for example?
Good question. So the actual answer is not that well. Because the animations are really quick. So I basically just add them and hope that the state doesn't change fast enough. I know that's really bad, but I'd already spent 4 weeks on it. And although it's a really important control, I don't know if it's that important. But in terms of how you would do it properly, or not properly, in this way, is you would basically, to your state, add anything that was necessary to render the animation. For example, we have the growing animation, which if you start tracking, the segment expands, and if you stop tracking it, it collapses. Now, the kind of naive way is to say, like, when you're rendering it, if you start tracking, you add the animation to expand. If you have any kind of complications where, or any kind of requirements where you'd have to change that animation, so if it was really slow and you pressed and unpressed, you don't want it to go all the way, you can keep track of the latest, either keep track of the latest position using the value that you've left it on at the presentation layer for a CA layer, or you can, the good thing about that is most of that is already handled for you by core animation. So if you've those kind of behaviors, like continuing from where the previous animation left off, or nulling it, or things like that, can actually be done on the CA layer, or within the CA animation that you add.
And following on this question, I don't know if it was intentional or not, but it looked to me like it had a little like idle state animation.
No,
No.
completely unintentional. Yeah.
That was my question.
Cool. What's my favorite color? It's blue. If that's it, then thank you very much, and I hope you enjoyed it.